We can use any poorly recorded multimedia from the internet, but for this tutorial we will head ourselves to the univariate linear regression section in the machine learning course in Coursera. The multimedia named the cost function. The download link lies in the right side of this label. We must then open the hard disk explorer by holding the Windows key and pressing E or Alt-Tab to it in case it is already open. We must reach the download folder, in my case the machine learning folder. I have already downloaded the file. We press the Windows key and type Audacity. I will use the 2.0.4 version. Clicking on it will open the required audio editor. We Alt-Tab back to the download folder and drag the multimedia file. Alt-Tab back to the Audacity window and drop it on the Windows client area. As you can observe, the audio track along its name and quality specifications were imported from the multimedia track. We vertically extend the stereo audio track to a maximum available screen space. We check in the edit menu, more specifically the preferences box. On the left side there is a library section. It will allow us to locate the FFmpeg directory. In case, as is mine, it is already downloaded. Since it is already located as well, I will click on No. In case you haven't downloaded FFmpeg yet, you can click on the download button or open your favorite web browser and type in the address bar www.ffmpeg.org. This is also the program we will use to remux and re-encode a multimedia file. Once the audio has been remastered, different download packages are available depending on the operating system you are using. Back at our audio track, we select the part in which the lecturer isn't talking yet noise is heard. We press Z to perform a zero crossing and select in the effect menu the noise removal filter. We select the first step so that the sound waves in the selection are parameterized so as to reduce the sound frequencies in the track according to the filter's parameters. We then select the whole track by pressing Ctrl A, since it is the only track in the whole project. By pressing Alt C and selecting once again the noise removal filter, we will be able to set the parameters by filling out step 2. We set the noise reduction to the maximum, sensitivity to 7.9, frequency smoothing to 500, attack decay to 0.12, and finally noise to remove. As you can verify, the filter is processing. It will last depending on the length of the track. The sound wave will wane substantially at the non-vocalized parts where the noise is isolated, whilst the uttered parts will only slightly change. Playing back the thin parts, no sound is heard and the wave is barely noticeable when zoomed in. Selecting the whole track and pressing Ctrl D will duplicate the track. Let's click on the title of the track and then click on the name option. Let's name it duplicate, then click on OK. Now select only the duplicate track, press once again Ctrl D and rename the new track Sibilance Isolation. This track will be used to isolate the S's. Click on OK, select only the Sibilance Isolation track, select on the effect menu Digital Fish Phone Spit Fish, adjust the frequency knob to 6 kHz, then click on the Listen switch, set the sense and depth knobs to max. This will correctly highlight the S's and rid of most of the rest of sounds. It will be applied to the Sibilance Isolation track. Clicking on OK will apply the effect. We will observe that most sounds will disappear. What will remain will be mostly the S's. There's an issue nonetheless. If we listen to the remaining waveforms, the last section containing other letters is subtly heard. Therefore, we select the last part of the wave, press Z to perform the zero crossing, and Ctrl L to silence that section. We play back the rest of the sound waves, checking whether there are unwanted sounds around them, and repeating the zero crossing and silencing steps performed earlier. For my illustrative purposes, I will skip the rest of the non-S silencing. We can now select the duplicate track, to which we will apply normalization and S-ducking filters. Click on the effect menu and select compress dynamics. Set the compress ratio to 1, slide the compression harness bar up to 0.8 or 0.9, set floor to more or less -45, set the noise gate fall off to more or less 8, and finally set the maximum amplitude to 0.99 to avoid clipping. Clicking on OK will allow the plugin to normalize the track and highlight the sections that in the original track were not emphasized enough. We will notice how this sound wave is expanded up to a higher amplitude. The whole track is normalized and balanced, but the S's have also been augmented, so the Sibilance Isolation track will serve as a duck track. For the duplicate track, the S's at the bottom track will attenuate the S's at the top. Both tracks coincide in the position of the S's. However, we need to increase the S's amplitude so that the duck effect is more intense. Let's check the frequency in this S by clicking on Analyze Flat Spectrum. We observe that the frequency range is from 5000 to 10,000 Hz. We now click on the Sibilance Isolation track and select in the effect menu the Equalization option. We will draw a peak between 5000 and 10,000 Hz. Then click on OK. The plugin will compute the frequency increase in the whole track. This will emphasize the S's in the Sibilance Isolation track. Even though the clipping is clearly observable, it doesn't really matter since it will serve only as a ducked track. We select the duplicate track, which lays on top of the Sibilance Isolation track. Then we head ourselves to the effect menu. We choose the auto dock filter. For the parameters, we set the dock amount to -28 decibels, maximum pause of 0.15 seconds, outer fade down length to 0.02 seconds, inner fade down length to 0.14 seconds, outer fade up length to 0.02 seconds, inner fade up length to 0.14 seconds, and finally threshold to -37.128 decibels. Click on OK. The auto dock filter will process the duplicate track in accordance to the amplitude shifts in the sibilance isolation track. We check that the SS in the duplicate track have been attenuated at the same spot where the sibilance isolation track shows amplified SS. We pressed Ctrl Z, and to revert it Ctrl Y. We check the swing of the SS waveforms. We then select the ripple noise from the duplicate track on the effect menu, click on noise removal, and once again on get noise profile. Then select the whole duplicate track, and on the effect menu once again select noise removal, and on the second step leave the parameters as they are. Clicking on OK will perform the noise removal for the second time. After the processing is finished, we will equalize the track to improve the voice performance in the multimedia file. We head ourselves to the effect menu and click on Equalization and set the points as you see it in the graph, slightly diminishing the low frequencies and maintaining the high frequencies. The bassy sound of the audio track will be attenuated. Click on OK. It will have performed the equalization. Playing it will allow us to appreciate the improvements. Now we need to export the duplicate track. We select the duplicate track. We click on File, then on Export Selection. As we can observe, I had already saved it. The file is named costfunction.flic. In your case, you must name it whatever you want. Then select the file type to flac, which is the highest quality because it is lossless. We set the options as they are by default, level to 8 and bitdepth to 24 bits. You will have to click on Save. Since I had saved it already, I will skip that step. We will now open the command prompt. In case it is not already open, you must press the Windows key and R, type CMD and press Enter. We must change the directory to the bin path of the FFmpeg package that we downloaded earlier and type ffmpeg.exe, which is the executable program to use as a remuxer and re-encoder. The first option specifier is -I, which stands for input. The second parameter is the actual path and name of the input multimedia file. In this case, it's c:\users/username/downloads/machine learning/costfunction.mp4. Then the next option specifier is once again -I, which indicates that the next parameter is another input file. In this case, it is the input audio file j:\remasteredml/export/costfunction.flac. Then we type -map to indicate that the next parameter is a mapping 0:0. Then -map once again for the next file mapping 1:0. The first mapping refers to the first parameter, which is an input video file being used as the first stream in the output file. The second mapping refers to the first parameter, which is an input audio file being used as the second stream in the output file. Since it is 0 indexed, that 0 indicates the first file. That 0 after the colon indicates the first stream from the first file, ignoring the second stream of that file. That 1 refers to the second file, which we specified after the second I, and the 0 after the colon refers to the first and only stream of that file. We then set as an option specifier the -v codec along with the copy parameter, which copies the input video to the output video without re-encoding, only remuxing. Then we type the option specifier -a codec, which indicates that the next parameter, libmp3 lame, is to be used for encoding the audio. The next option specifier -ac indicates the quantity of audio channels. In this case, it will be 2. The next option specifier -b:(a) indicates that the next parameter is the audio bitrate, in this case 128K. Reviewing the audio options, -a codec is specified with an MP3 encoding library called lame MP3. The bitrate is set to 128 kilobits per second, and the audio channels are set to 2, one for each channel in the stereo mix. Finally, let's type the name of the output file. The format will be assumed to be the one indicated by the extension of the file, in this case MP4. The set of parameters are ready to mix the files into one multimedia file. Now we are ready to execute FFmpeg along its parameters. We press enter. We can observe the input and output files, specifications, and the mapping of the streams within such files. We can look at the processing bitrate, time, size, quality, frames per second, and frame count. On the stream mapping section, we observe that the first input file's first stream is being copied to the only output file's first stream. The second input file's first stream is being mapped to the only output file's second stream. And this audio is being converted from flac to lame MP3. It will take some time to compute the remuxing and conversion. Once it is finished, check the bin directory of FFmpeg, where the output file will show up by default. We type its name, remastered costfunction.mp4, press enter, and allow the default video player to play the recently created multimedia file. Now we can listen to a better audio track along the video. This technique can be applied to any multimedia file whose audio is lacking. Thanks for listening.